For this video project, I will be discussing the factorial design for three factors, also known as the 2 to the third design. For this experiment, I will be discussing multiple variables. Since it is a 2 to the third design, that means we will have three factors. For our example, we're going to be having W, F, and D that represents weight, force, and distance. For this 2 to the third design, we will run it 8 times in order to recognize and establish the multiple possible combinations and test how all these factors can have an effect on our main design. This work by setting our factors to 1 will represent the main low possibility and 2 for the high possibility of the design matrix to happen. For any 2 to the third experiment, it is represented by this base model which follows as a standard order number. The first factors goes from 1 to 2 and 2 to 1. The second one goes from 1 1 to 2 to 2. And for the third and the last factor, it runs from 4 1s to 4 2s. The key to gather data set for our model is by gathering them randomly. Also, they should be independently, meaning we can mix our factor set to get accurate data set at the end. Also, assuming that these factors will not work against our model. In this model, we cannot take into account factors such as air, reactions coming from the ground, and friction, which leads to take us to this figure that can help industrial engineers define some factors that will make the crane work or not. This model can help engineers decide if they will be able to obtain an actual working crane and to put it to use in construction or any other purpose. Three big important factors that cause a failure in the crane is the weight of the crane cam, the force that the crane can hold to be able to stay in the ground, and the distance from the crane to the load. Not satisfying these factors will be a failure and it will be causing disasters in this world. These factors represent our 2 to the 3 experiment in this field of engineering, which can help a lot of engineers to build something based on our matrix model.